Welcome to Lalpur Khalsa College Online Pathshala. Today we will be discussing the topic OSI reference model, role of each layers, advantages and disadvantages of OSI reference model. So let's start with the topic. OSI or Open System Interconnection Model was developed by International Standard Organization ISO. It gives a layered networking framework that conceptualizes how communication should be done between the heterogeneous systems. It has 7 interconnected layers as shown in the diagram. The 7 layers of OSI model are physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer as shown in the following diagram. The physical layer, data link layer, and the network layer are the network support layers. The layer manage a physical transfer of data from one device to another. Session layer, presentation layer, and application layer are the user support layers. These layers allow communication among unrelated software in dissimilar environment. Transport layer links the two groups. The main functions of each of the layers are as follows. That is, we start with the first layer. The first layer is the physical layer, which is layer 1. It deals with transmission of individual bits from one node to another over a physical medium. The main functions of the physical layer are as follows. It defines the physical characteristics and functions of the physical devices and interfaces so that transmission can occur. It states the number of pins in each of the devices as well as the purpose of each pin. It lays out the transmission medium and type of signal for transmitting the bits, that is, electrical pulses, optical pulses, or radio signals. It also defines the procedure of encoding of bits, for example, how many volts should represent a 0 bit and 1 bit in case of electrical signals. It states the data transmission rate, that is number of bits transmitted per second, and the duration of a bit, that is how long a bit stays. Also, it defines the topology, that is physical layout of the network devices. It also states the direction of transmission, that is whether the transmission is in simplex mode, half duplex mode, or full duplex mode. Moving on to the next layer, the data link layer, that is layer 2. It converts the raw transmission facility provided by the physical layer to a reliable and error-free link. The main functions of this layer are: it brings up the stream of bits into data frames having sizes from a few hundred to a few thousand bytes. It ensures distribution of the frames to the different systems. For this, it adds a header to the frame containing the address of the sender and the receiver. In case of reliable connection, this layer ensures that the receiver sends an acknowledgement frame. In absence of acknowledgement frames, frame retransmission is done. That is, frame retransmission is also the responsibility of this layer. It also has mechanisms to identify duplicate frames. The data link layer ensures flow control of transmissions so that a fast sender does not drown a slow receiver. In case of broadcast networks, this layer also controls access to the shared channel. Now moving on to the third layer, that is the network layer. It controls the source to destination delivery of data packets across multiple hops, also known as nodes. It controls the operation of the subnet. The main functions of the network layer are: it is responsible for routing packets from the source host to the destination host. The routes can be based upon static tables that are rarely changed, or they can be automatically updated depending upon network conditions. The data link layer assigns the physical addresses locally. When the data packets are routed to remote locations, a logical addressing scheme is required to differentiate between the source system and the destination system. This is provided by the network layer. This layer also provides mechanism for congestion control. The network layer tackles issues like transmission delays, transmission time, avoidance of jitters, etc. Moving on to the fourth layer, that is the transport layer. It is responsible for delivery of an entire message from an application program on the source device to a similar application program on the destination device. Its main functions are: it delivers a message from a specific process of one computer to a specific process in another computer. The transport layer adds a port address to the header of the data packet. It divides the message into smaller segments such as that each segment contains a sequence number along with the port address. Also, it ensures that the segments arrive correctly at the receiver end and then reassembles them. It provides an error-free point-to-point channel for both connectionless and connection-oriented services. It isolates the upper layers, that is the user support layers, from any changes in hardware technology in the lower layers, that is network support layers. It also identifies errors like damaged packets, lost packets, and duplication of packets, and provides adequate error correction techniques. Now moving on to the next layer, which is the session layer, which is layer number 5 of OSI model. This layer is responsible for establishing, managing, synchronizing, and terminating sessions between end-user application processes. It has the following main functions. It works as a dialog controller. It allows the system to communicate in either half duplex or full duplex mode of communication. It is also responsible for token management. Through this, it prevents the two users to simultaneously attempt the same critical operation. It synchronizes communication. It also adds synchronization points or checkpoints in data streams for long communications. This ensures that data streams up to the checkpoints are successfully received and acknowledged. In case of any failure, only the streams after the checkpoints have to be retransmitted. Moving on to the next layer, layer number 6, that is the presentation layer. This layer ensures that the messages is presented to the upper layer in a standardized format. It deals with the syntax and semantics of the messages. Its functions are: number 1, it encodes the messages from the user-dependent format to the common format and vice versa for communication among the dissimilar systems. Number 2, it is responsible for data encryption and decryption of the sensitive data before they are transmitted over common channels. Number 3, it is also responsible for data compression. Data compression is done at the source to reduce the number of bits to be transmitted. It reduces the storage space and increases the file transfer rate. It is particularly useful for transmission of large multimedia files. And the last layer of OSI model, this is the application layer, layer number 7. It is the topmost layer of OSI model. It specifies the interfaces and supports services to the end users for network access. It provides a virtual network terminal through which a user can log on to the remote host of the network. It also provides facilities so that a user can access and retrieve files in a remote computer for local usage, as well as manage and store files on a remote computer from the local computer. It provides email services. It helps to retrieve global information and services by providing access to distributed databases resources. So these were all the basic functionality of each and every layer of OSI reference model. Now let's discuss about the advantages and disadvantages of OSI model. The various advantages of OSI model are: OSI models clearly define the services, interfaces, and protocols. It explains which layer services are supported. It also explains how the procedure placed about a specific layer will create its services and how it can help the protocols to do their task. The protocols of ISO model are exceptionally private and can be returned with other appropriate protocols quickly. It is general model. It provides connection-oriented and connection-less services. Because of the layered architecture following the abstraction services, the change appearing in one layer does not force the others. Hence, it gives more security and flexibility, unlike having all features accumulate together into an individual layer. So next are the disadvantages of the OSI model. The major disadvantages of this model is: sessions and presentation layers are not of much use. The OSI model was developed first and then the protocols were created to conform to the network architecture requirements. Thus, in real life, there is an issue of the proper protocol in the model. The OSI layers are inter-independent. OSI layers cannot operate in parallel. Each approaching layer requires waiting to get the data from its predecessor layer. For instance, the application layer gets the data from the presentation layer, and the presentation layer needs to wait to get the data from the session layer, etc. The performance of the TCP and IP protocols was earlier the release of this model, and thus some organizations are uncertain about using it. A few layers such as the presentation layer and session layer have very few services when virtually set up. So these were some of the advantages and disadvantages of OSI reference model. And with this, we finish with the topic of OSI reference model. Thank you so much.